All right, welcome back. We're in part 2 of our math lab investigating inverses. In part 1, we looked at them algebraically. Now, in part 2, we're going to investigate them graphically. So let's start by graphing the function f of x, 2x plus 3. So you have two options here for graphing. You could use your slope-intercept form. So our intercept is 3, so we go up 3 on the y-axis. And then 2x, 2 is the slope. That's rise over run. So we're going to rise 2 and run 1 to the right. Rise 2, run 1, rise 2, run 1. Or down 2 and to the left 1. Down 2 to the left 1, down 2 to the left 1, and so on. Okay, the other way that you could sketch that graph, if you're not sure about slope-intercept form, you can pick some numbers for x and put them in to find the y that goes with it. So if we evaluate f of -5, that's 2 times -5 is -10, plus 3 is -7. And we can see on the graph there's our point at -5, -7. Okay, then if we put in -3, 2 times -3 is -6, plus 3 is -3. And there's that point at -3, -3 on the graph. -1, 2 times -1 is -2, plus 3 is +1. And there's our point at -1, 1. And then so on. 2 times 1 is 2, plus 3 is 5. 2 times 3 is 6, plus 3 is 9. 5 times 2 is 10, plus 3 is 13. Okay, now let's sketch the graph of the g of x. We've got 1/2 times x minus 3 over 2. Now, it's tougher to sketch the graph using slope-intercept form when your y-intercept is a fraction. So in that case, it's going to be easier for us to use our graphing calculator to look at some xy pairs for this graph. So if we go to our y equals, clear out what we had before. Okay, in our y1, we're going to put in 1/2 x minus 3 over 2. Okay, just like we see here. And then if we do second graph, see up above that opens our table. So we can see at 0, the point -1.5 is on the graph, 1, -1, and so on. If I use my arrows, I can backspace up to get to where my xy table begins. So -7, -5 would be my first point on the graph. So -7, -5. Okay, then my next point is -3, -3. Okay, then we have +1 and -1. Okay, then we've got to scroll down to 5. So 5, 1 is on the graph. And then we'll scroll to 9. And 9, 3 is on the graph. And then we'll come down here to 13, and that's a 5. So when we sketch these points, we're going to go to -7, -5, then -3, -3. That point coincides with f of x. 1, -1, then 5, 1, 9, 3, and the 13 is off of the graph, so we won't be able to sketch that. Okay, so what is the relationship between the ordered pairs of f of x, that's our red function, and the ordered pairs of g of x, that's our blue function? So if we look at our first pair here, -5, -7, we can see that they switch places, -7, -5, right? -3, -3, if I switch them, they look the same. But -1, 1, I can see they switch places and become 1, -1, right? 1, 5 becomes 5, 1. 3, 9 becomes 9, 3. 513 becomes 13 comma 5. So the relationship between the ordered pairs, the x and the y switch. X comma y becomes y comma x. And what is the relationship of these two lines, the blue and the red, related to that dashed line, that dashed green line through the middle, y equals x? So as I compare my points, right, 5, 1 and 5, 1 and 1 comma 5, right, those 2 points, they come together and meet here at that green line. If I look at 3, 0 and 0, 3, right, again, they come together and meet here at that green line. These 2 points, right, at -5, -7, -7, -5. Again, they come together and meet here at that green line. So that green dashed line, y equals x, that's a reflection line. If I were to imagine folding this paper along that green line, the red and the blue functions would overlap. They would touch each other. So that's how these graphs are related. F of x and g of x have symmetry, like a fold, over the line y equals x. If you were to fold that graph in half along that green dashed line, f of x and g of x would lay right on top of each other. So knowing that relationship between the inverses on the graph and that line y equals x, I can sketch the inverse just by switching the x and y in the ordered pair. So if 1 comma 4 is on the graph of the function, then 4 comma 1 is going to be on the graph of its inverse. If -2, -5 is on the graph of the function, then I can go to -5, -2 to get a point on the graph of the inverse. And then where the line intersects with y equals x, I can also put a point because these two functions, the function and its inverse, those are going to always intersect along that fold line or the line of symmetry. So go ahead and pause the video and you're going to sketch the inverse for the next two on the lab paper. So number 4 and number 5. And then when you're ready to check them, you can resume the video and we'll go over them together. So in number 4, right, when the line passes through -4, -3, its inverse will go through -3, -4. We're switching the x and the y, right? The point 4, 1 becomes 1 comma 4, and they intersect the function and its inverse graph over that diagonal line of symmetry, y equals x. In number 5, we're going to switch the x and the y for 0, 3 to get to the point 3, 0. 2, -2 becomes -2, 2, and there's their point of intersection along that symmetry line, y equals x.